Okay, so let's see here. So which is not true about the adrenergic receptors? And we had an overwhelming response for D. So let's take a look at D. Alpha-1 and alpha-2 receptors are generally inhibitory and have a greater affinity for epinephrine than norepinephrine. Okay, so that is correct because that is not true, right? And the other options, as you should have gone through, were true. So alpha-1 and alpha-2, excitatory, and they prefer norepinephrine. Beta-1 and beta-3 we know are excitatory and have equal affinity for norepinephrine and epinephrine. And then beta-2 we know generally inhibitory, and it prefers epinephrine and then norepinephrine. Okay, good. So the answer there was D, all right? Let's look at another question. So I'm gonna relaunch this. Okay, so that is a minute, so let's see. So the question is, after a neural signal, sodium flows into a muscle fiber and produces a depolarization that's called an end plate potential. That is similar in many ways to the excitatory postsynaptic potentials, but how is it different? And here we want to remind ourselves that this EPSP is really referring to a graded potential. So basically it's asking, how does an end plate potential differ from a graded potential? Okay, so we had a lot of response for D, and D says that an end plate potential or end plate potentials normally have enough amplitude to contract the muscle. And that is correct, okay? So an end plate potential differs fundamentally from a graded potential. Remember we said graded potentials such as EPSPs and IPSPs are not strong enough on their own to really do anything. They don't have enough of an amplitude or enough of a duration to bring about any meaningful change. End plate potentials we know do, so we can kind of compare them to action potentials. Let's go through some of the other options. So end plate potentials can sum together, so can EPSPs because they're graded. Graded potentials have the ability to sum. Hormones can also cause muscle contraction. This one is not true, okay? So acetylcholine is the only neurotransmitter that can bring about muscle contraction, and it's not a hormone. So when we talk about hormones, we're speaking about norepinephrine and epinephrine, and those are not involved in any way at all in the somatic nervous system or the neuromuscular junction. C is that end plate potentials are excitatory, well, so are EPSPs, so that's not a difference, okay? End plate potentials are excitatory, EPSPs are excitatory, so that is not a fundamental difference, okay? And so that makes D our correct answer. Alrighty, so our correct answer here is D. End plate potentials can bring about contraction. And let's look at one last question, and then we will call it a day. So let's launch this again. Okay, so let's look at some of the answers here. And some people are still polling in, so I'll give it another 10 seconds or so. Okay, so let's see what we've got here. So which is not an anatomical arrangement for a sympathetic signal from its point of origin to its effectors or effector tissues? And so we had a lot of response for C. And C says it's synapses on the sympathetic chain, then the adrenal. Okay, and that is not an anatomical arrangement, so that is correct. So the other options, synapses at the sympathetic chain, then the postganglionic neuron synapses on the organ, so that's an option. That's the most common route. Synapses on a collateral ganglia, then our postganglionic neuron synapses on the effector organ. That is also one of our options, our second route for communication. And then D, synapses on the adrenal medulla of the adrenal gland, which we know is the third route of communication. So C is incorrect because it does not synapse onto the sympathetic chain and then the adrenal gland. It'll synapse either on the sympathetic chain and then the effector organ, or on the adrenal gland, and then release that hormone. So C is the incorrect option.